Hello everyone, welcome back to Sanjay Academy. So today's class we are gonna talk about mechanics, which is the first chapter, that is laws of motion for the IIT-JEE exam and NEET exam 2020. Right. So without any further delay, we just go to the first question. Yeah. So we have the first question, that is a particle of mass m is acted upon by a force F, which is given by the empirical law, that is F is equal to R by T square, hence V of T. If the law is to be tested experimentally by observing the motion starting from rest, the best way is actually to plot. They are actually given like few options, which is four options they have given, right? We have to find which one suits the best. Let's see how we will do the question. But before starting the question, I just want you guys to take 2 minutes, as always, 2 minutes break, right? We just pause the screen for 2 minutes, try to do it by yourself, then resume playing and do it. Then check the answer. Clear? So let's start, guys. So here, from the question given, right, for the first question, from the things given, I can write F is equal to R by T square times V of T. Am I right? But F we know is basically mass times acceleration, or I can write it as m dv by dt, which is equal to R by T square times V of T. Am I right? So if we integrate on both sides, when we integrate on both sides, so what we're going to get is integral dv by dt is equal to integral r times, it goes there, dt by mt squared, right? So when we integrate, what is ln dv by dt, what we are going to get is ln v is proportional, sorry, just a moment, yeah. So ln v, that is natural logarithm, which is equal to minus r by mt on further differentiation and solving it. So we can write ln v is proportional to 1 by t. So this is the best part to plot it. So basically for the first question, our option is going to be this. You can see here, this is our option A, right? So the correct option is going to be option A. So that's our answer, right? It's just in this question, it's just simple integration, right? Just simple integrations. Whenever we get something as a function of, as a function, basically, there is some point of calculus involved in it. It can be either integration or it can be differentiation, right? So let's go to the second question. Again, guys, as I've told you that when we go through the question, just take 2 minutes. Once you read the question, just take 2 minutes time, take your break, and then you will be like resume the you know the video. Then you can check whether you got the same answer or not. So here in question number 2, a large number of identical beads, each of mass m and radius r, are strung on a thin, smooth, rigid horizontal rod of length L, where L is very much greater than R, because R is basically the radius, and it rests at random positions. The rod is mounted between two rigid supports, which you can see here. This is one rigid support and this is another rigid support, right? So if one of the beads is now given a speed v, right, one bead is given a speed v, the average force experienced by each support after a long time is, we have to assume the collisions is elastic. Okay, so we have beads, right? Identical beads, right? And each of them are having mass m as well as they are having radius r, right? And they are strung on a thin, smooth. digit horizontal rod that is given over here. Let's see how we'll approach the question. Guys, you take this 2 minutes break, and I mean, not actually break, 2 minutes, you take the time to do the question, right? So let's go, just move forward. So if you consider, can I say that for our question number 2, the space between the space between the supports, the support rods, or the space between the supporting rods, for the motion of beads, for the motion or movement of beads, it is going to be, actually the total length is given as L here, right? L. And yes, just a moment. Yeah. So N beads are there and R is a radius. So can I say, yes, yeah. So can I say the total distance is going to be L minus 2 and R? So the average force experienced by each support, by each support, it is going to be F is equal to 2 mb by 2 times L minus 2 nr by V, which is mv squared by L minus 2 nr. Why it happens is, if we have this place where it is the total length, right? So mv, and this is going to be the total length is L minus 2 nr. Why? Because if a bead, right, it is moving in this position and is coming back in the position, so the change in momentum here is going to be 2 mv, right? Right, mv, and this will be minus mv. Then totally it is going to be the change in momentum. What you get is mv minus mv, which is basically 2 mv, right? So that's how we got the answer. So mv squared by L minus 2 nr is going to be your answer. That is option B, right? Option B is your answer. We can check it, just a moment. mv squared by L minus 2 nr. So option number 2, that is going to be our answer. So let's go for the third question. Yes, a body of mass 5 kg under the action of constant force, that is Fxi plus Fyj, has velocity at t is equal to 0 seconds as v is equal to 6i minus 2j meter per second, and t is equal to 10 seconds as plus 6j meter per second. We have to find the force. So guys, let's do it. Again, you take the 2 minutes break. So mass is 5 kilogram, right? So what is the velocity at time t is equal to 0? It is mentioned as 6i minus 2j meter per second. Am I right? So what is the velocity at t is equal to 10 second? So that is given only as 6j meter per second. There is no I thing there, or z. So F is the force, is the thing that we have to find. What is force? So force, we can see that force is equal to mass times acceleration. The acceleration is b minus u by t. So can I write the acceleration as 6j minus, that is the final velocity is 6j, minus initial velocity is 6i minus 2j by time taken is 10 minus 0. So the acceleration is going to be minus 3i plus 4j by 5 on solving meter per second square. So we know the force is equal to mass times acceleration, so which is 5 times what is acceleration, minus 3i plus 4j by 5. Am I right? So this 5 and this 5 gets cancelled, and your answer is going to be minus 3i plus 4j Newton. So this is going to be our answer, and the correct answer is option A. A lot of option A is in the answer, right? So this option A is your answer. Clear? Yeah, guys, let's go for the fourth question. A uniform sphere of weight W and radius 5 centimeter is being held by a string, as shown in the figure here. The tension of the string is what we have to find. Let's do that, guys. Now, before going further, yes, again, first I will explain this in the figure, right? So this is a string, am I right? So there is some angle theta, right? As we know that the tension is something that acts in this way, right? Tension T, right? And this distance is mentioned in the question as 5 centimeter. I'm going to just name it as P, then this is O, and this is Q, right? So what is this? This will be our weight. So where were we? About the OP part, we were there. Just a moment. So if this is 8 and this is going to be 5, so totally this is going to be 13, am I right? And this we know is 5, and as we have discussed, this is going to be W, then what is this is theta, this is going to be cos theta. So guys, I have mentioned it's a 0 and this is Q and this is P, am I right? So when we do that, listen, what is PQ? Root of P square minus OQ square is going to be root of 13 square minus 5 square is going to be 12. So this distance is going to be 12, right? So if it's going to be 12, listen, that what is tension is equal to, right? The tension is going to be, I'll draw that well so that you can understand that better. Yeah. If the tension is going to be in this direction and this is W, this is W cos theta. So we can directly say that the tension is equal to W cos theta, and W cos theta we can get it as 13 by 12 Newton from the figure. So this is going to be our tension. So if you look at the answer, we have an answer which is option D, right? Option D. So cos tension, which is W cos theta, is going to be, I'm sorry, yeah, W cos theta, it is going to be cos theta is 13 by 12 times W. This is going to be an answer because this is equal to a tension. So this is the tension, right? Let's go for the next question. Yeah, this is going to be our last question, hopefully. So we will just evaluate it completely, let how it goes and how. So in the figure, there are two blocks A and B of weight 20 Newton and 100 Newton, right? So A is 20 Newton and B is 100 Newton. So we will draw that at first. A is 20 Newton and B is given as 100 Newton. Perfect, fine. So these are being pressed against a wall by a force F as shown in the figure. So we got a force. So he is the guy who is pushing a box here, right? So yes, let's come back. If the coefficient of friction between the blocks is 0.1, which when we get question like here, this the coefficient of friction over here is 0.1, and between block B and the wall over here, this one, which is going to be 0.15, okay, the frictional force applied by the wall on the block is, right, the frictional force applied by the wall on the block. So this is what we have to find. So guys, let's see how we are going to approach this question. So we know that if this block B is isolated, it is going to go down, right? The force acting is downwards, so obviously it's going to go down, right? If this is going down, the force acting on it, the frictional force acting on it, right, is going to be, if this is, where is our imply, no, green is fine, yeah. So what happened over here is this block A, for block A, there is a frictional force which acts in this direction, and for block B, the frictional force will act in opposite direction because they are action reaction pairs, right? Similarly, there is a force that acts in the upward direction against the motion, which is F2, and this friction is due to the wall, and there is a force of normal reaction, and this normal reaction, right? This normal reaction is acted on the block B by the wall, right? by the wall. So now let's do this question step by step. So here in this type of question, right, just listen. So if the blocks are stationary, we can say the normal reaction force is equal to the force applied, the applied force F, and the normal reaction is going to be the same, right? And F1 is equal to 20 Newton, right? So you can see that there are only two forces. One force is this, and the other force is this. So if A should be stationary, the sum of upward force is equal to sum of downward force. F net is 0. So in case of F2, what is F2? If F2 you consider, this is block B, right? And this is going to be F2. So there is this F1 as well as 100 Newton is acting downward. So F2, we can simply write it as 100 plus F1. But we know that F1 is 20 Newton. So we can write 100 plus 20, which is equivalent to 120 Newton. Am I right? So if it is going to be 120 Newton, let's just say that there is one full block, and this is going to be the right. So this is the force acting. So this is going to be 120 Newton, right? If you consider the entire block, I mean the two blocks, if you consider it one single system as one single system, right? Due to equilibrium, what will happen? Due to equilibrium, we can say this F is equal to 120 Newton. But what is this F? So when you look at it, we can understand that that F is actually the force of friction, right? What is the thing we have to find? We have to find the frictional force applied by the wall on the block. This is the force of friction applied by the wall on the block. Am I right? So that's it. So this is our answer. F is equal to 120 Newton. So that's going to be our option A. So there's a lot of option A in answers, right? So guys, that's all with the Newton's laws of motion mechanics part. So please do share the channel if you like it. For more videos, please subscribe and like the video if you have liked the content, and please comment below what are all the improvements that you want to, and what are the next video which you want to see on. So if you want to start the real classes as well, so please let me know in the comment section below. Thank you so much guys for your love and support. Thank you so much. We'll see you in the next video.